So if x goes to infinity, that's similar to b going to infinity, yes? So then we have limit as b approaches infinity. So then this is infinity minus the natural log of 2. So this actually doesn't have a finite area. When this happens, we say that the integral is divergent, or the integral diverges. So this diverges, meaning it doesn't have any area underneath. It just keeps growing and growing and growing and growing. If we graph this at the very beginning, I mean, you might think that it might have a limit, but it doesn't. And there's a specific reason why, but we'll talk about that in a minute. So when you get infinity for your improper integrals, or negative infinity for your improper integrals, you would say that it diverges. If you get a number, you would say that it converges. So when your instructions say tell whether it diverges or converges, you just be telling whether you get a number or you don't get a number. Now I want to talk about this, because both of the things that we've done were of this form. Do we understand that? Yeah. If p is greater than 0, what do you think I'm going to write? Greater than 1. Here. Sorry, yes, thank you. If p is greater than 1, come on, how do I? There we go. If p is greater than 1, that would be which example? Example 1 or example 2? That would be example 1. So I'm going to say if p is greater than 0, the integral converges. And it turns out that if p is...
Wasn't p negative?
No. P was positive. I just brought it to the top, and then it became negative. Yeah?
Oh.
That's why it was negative. In the original, it was positive. So if p is less than or equal to 1, so that's what I'm going to change, then what do you think is going to happen? Yeah, the integral diverges. But that only works when you have infinity in the top. If you have somewhere else, you would have to change it around a little bit. There's one more example that I want to show you. But this is kind of a shortcut. If you have these specific cases, taking note of where the infinity is, if you have this specific case, then you can right away know if it diverges. If it converges, you'll just have to do the math anyway. Are we okay? Yeah. All right, last example. That's something else. I'm going to do way up here. So this is the last example. I'm going to do it kind of quickly. This does not look like an improper integral. Can anybody see why that it is an improper integral? Because the integral is undefined at x equals 3. Yes. There is some infinite discontinuity. If we were to graph this, we would see there's an asymptote when the bottom equals 0. Yeah? So we actually do need to pay attention to the integrand and our limits of integration. Suppose I went, I guess it wouldn't make sense for this problem, but sometimes the integral can be undefined. Suppose I had this. This will illustrate my point. If I didn't have the square root anymore, I just had this, and I went from 1 to 4. It's continuous at 4, correct? It's continuous at 1, correct? But this is still an improper integral, because in between 1 and 4, there's 3. Yes? So really what I would have to do is go from 1 to 3 of that stuff, plus from 3 to 4 of that stuff. And then I would change this to a b, and do 2 separate problems. Do we understand that? Yeah. That's not going to happen today, but that's just looking forward for tomorrow. So, let's go back to the original problem. Square root and 3. So I'm just going to change this to a b, 1, and then 3 minus x to a negative 1/2. What would you use here? Yeah, if you don't want to do, I guess, reverse chain rule, you can use u sub. U equals 3 minus x, du equals negative dx, dx equals negative du. So this negative, I'm just going to put on the front of my integral. All right, then I will have, I'm going to forget about the limits of integration for now because I'm changing stuff. So I have u to the negative 1/2 with a negative out front and a du. Add 1, that would be u to the positive 1/2 times 2, and then that negative out in front. And then I'll change it all back. Negative 2 times 3 minus x to the 1/2, evaluated from 1 to b, and the limit as b approaches what? 3. Ooh. If we just wrote 3, it would be a two-sided limit. From the left. Do we understand that we need to approach 3 from the left side? Because the limits of integration only include the left side of 3. Do we understand that? Okay, cool. So, not b. 3 from the left. If we approached it from the right side, our function's not defined there. We have imaginary values in the bottom, so that wouldn't make sense. And then we just plug stuff in. So, negative 2 times 3 minus b, underneath a radical, minus negative 2 times 3 minus 1. I feel like it should have been a negative 1. Oh well. To the 1/2. Yeah? That changes, and we're taking the limit as b approaches 3 from the left. So what does this go to? What does the first part go to? Yeah, it goes to 0. So that goes away, and then our answer is just 2 root 2. I wrote it right.